more piecewise functions. So we studied piecewise functions in a previous unit, but we're going to expand on that and include some more interesting functions this time. So remember, a piecewise function is where we have several different rules and certain domains we use them on. So these items on the right tell us which x values we're allowed to use in this rule. So this is a linear function, x plus 3, so y-intercept of 3, slope of 1, but we are only allowed to graph it for x values less than or equal to -2. So if I plug in -2 plus 3 gives me 1. So I'm going to plot -2, 1 as my first point. I can put a solid point there because we are allowed to equal that value. Now, the slope is 1, so that would mean up 1 over 1 to the right, but I'm not allowed to go to the right. I have to use x values smaller than or equal to -2, so I'm only allowed to graph over this way. So I'll use my slope to go down 1 over 1 to the left and plot my points until I can't fit any more on. So there's the first piece. Now, the next piece is an absolute value function, and I'm only allowed to use x values between -2 and 2. So at -2 and 2, I'll have to use open circles because I can't equal those. So if I plug in -2, the absolute value of -2 is 2. So I'll put my open circle right there. Absolute value of -1 would be 1. Absolute value of 0 is 0. Absolute value of 1 is 1. Absolute value of 2 is 2, again with an open circle because I'm not allowed to equal that x value for that rule. And then the final one, when x equals 2 or bigger, I'm supposed to do my quadratic x squared. So if I plug in 2 squared gives me 4, and I have a solid dot there because I can equal 2 for that rule. If I plug in 3 squared would be 9, so it's going to be up here somewhere, and so I'm going to have that parabolic curve segment right there. And so there would be our graph of that linear absolute value and quadratic function chopped up into pieces and put together here. All right, so the next one, we've got a rational function. We've got a reciprocal function. The x is in the denominator, and we are only allowed to plot this one for 4 or smaller. Well, 4 is actually our vertical asymptote. So at 4, we will draw in our dashed vertical asymptote, and then I can only use values smaller than that. So if I plug in 3 minus 4 gives me -1, so 1 divided by -1 gives me -1. Keep in mind this also has a horizontal asymptote at 0 because it's bottom heavy. The degree of the denominator is 1, degree up here is 0, 1's bigger than 0. So bottom heavy, anytime it's bottom heavy, it's always the x-axis, y equals 0. So I know we're not going to touch or go above that. So we're going to have this piece down here, but we can find a few more points here. If I plug in 2 minus 4 will be -2, so I'll get -1/2. If you would plug in 3.5 here, 3.5 minus 4 gives you -1/2, but we don't divide by a fraction, we multiply by its reciprocal, so we'd get -2. So we could plot that one as well to see that it's going to go, to help you with that shape. But so we're going to have this piece of this reciprocal function graphed right here using x values less than or equal to 4, but again, we couldn't equal 4 because that's the asymptote. And then beyond 4, we're supposed to just equal -4. So, open circle on the 4 over to the right for that constant function there. All right, and the last one here, this one, we scaled our x-axis in terms of radians because we are going to graph the cosine and the sine functions from previous units. So first, we're supposed to be at a constant value of -3 for everything less than -3/2. So open circle there on the -3/2 since we can't equal it, and then continuing to the left, that solid value down there at -3. And then we're graphing the cosine function between -3/2 and 0. So, if we plug -3/2 in for x, -3/2 or -3/2 pi means that we are actually at pi over 2. So there the cosine is 0. So we're going to have an open circle on 0. Because remember, cosine starts up on a high, and because we have an amplitude of 2 right here, it would start here at 2, but I can't use a solid dot because I'm not allowed to equal 0. I have to be less than it, so I got to change that to an open circle, and then then we would go down to our midline, and then it would have been a minimum, which again, because of that amplitude of 2, would be down at -2. So here would be that piece of a cosine curve. And then we're graphing the sine curve from 0 to 2 pi. Again, we can't equal either. And sine starts on the midline. Because the amplitude here is -1, normally for sine function, we start down and then we go to our maximum, midline, minimum. But because of that -1, it's going to be reflected. So it's going to go down to a minimum first. So it's going to go down to -1, and then back to the midline, up to the maximum, midline. And oops, can't have a solid point for that last one. Got to be an open circle because, again, we're not allowed to equal 2 pi. We just have to be less than it. So then we'll sketch in that shape. And there's our piecewise function graph. So again, we got to pay attention to these values. So this tells you the x values you're allowed to use for this rule. So in this rule, it exists only for x values smaller than -3/2. So here's -3/2. We can't equal it, so it gets an open circle, and then things smaller than it, so to the left of it. This one, we had to stick with x values between -3 pi over 2 and 0. So again, we had open circles on both of those since we couldn't equal them. And so we figure out this rule and graph on that little section. And then for this section, we are using this other rule that we follow. And just a good opportunity to review graphing cosine and sine. So remember, cosine starts up on a max and then would go to midline, minimum, and so on. Or so back this way, midline, minimum, midline. Remember the number out front is called our amplitude, and so that's how high we go or how far away from the midline we go. And then for this last piece, it was the sine function. So sine starts on the midline and normally goes to a maximum, but if we have a negative out front, then it's reflected. So technically, remember, amplitude is always positive, so the amplitude there is 1, but because we have that negative out front, it's reflected. So that's why we went midline down to the minimum of -1, midline, maximum, midline. So just a little more on piecewise functions.